Welcome to a new video. Today we are going to build a data science project. In this video I'm going to use a dataset from Kaggle and I'm going to leave its link in the description of this video. This dataset is about football players and their salaries, and let's just directly start coding. We are going to work on a regression problem and we are going to do data analysis, feature engineering and machine learning. So we can start with importing the libraries that we are going to use. We are going to import pandas and we are going to use matplotlib. Also we are going to import it like pyplot as plt, and at the first step we just need this two for data analysis and the data visualization. So we are going to start by loading the data set, and I'm going to set it as data frame, and I will use read CSV from pandas and my dataset name in here. And you can just check it like df.head for displaying the first 5 rows if it's loaded successfully, and here it is. So we have both numeric and categorical columns. Like we are going to predict this wage column, and we have numeric values and categorical values. Also, I want to tell you that this apps is the appearances in the matches, and this caps is appearances on the international matches. Like this is how many games they played on the matches. You can think it like that. We have age, club, league, nation, position, and appearances at that side. Great, so we can display basic information about our dataset using df.info, and this brings memory usage, data type counts, non-null value counts, and here it is. So it's a nice way to explore the data frame at the first step. And we also check the head for displaying the first 5 rows. Also you can use tail for displaying the last rows of the data set. And we can get the summary statistics for the numerical columns like using df describe, and it will return the summary statistics. Like for the age, our lowest value is 18 and the maximum value is 41, and for the appearances side, 0 is the minimum value and the maximum is 715. And we can just check standard deviations for how the data is distributed. We can check the means, and I think that's enough for the describe side. So at the next step we can check for the NA values. So what we will do is we will say data frame is NA, and if we run this like this, we are going to get booleans like if there's any NA valued rows or entries, it will return true at that side, and if we just add sum after that, we are going to get the counts for each column. And we can see that we don't have any NA valued rows or values in our data set. Great. So at the next step, let's check for the duplicates. Like duplicates are the same entries, we can think it like that, and we are going to check them row wise because some values can be same, like 2 players can be at the same age, but if the entire row is same, then we are going to call that as duplicate. So we will say data frame duplicated, and we will use just run like this. You are going to see false, 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 and if you add sum, you are going to get the count of the duplicates, and we have 65 duplicated rows. So I'm not going to use them, so let's just delete them, and we are going to use drop duplicates, and this is the function we need for removing the duplicates. But there's a problem. If you run this function like this, it's not going to modify the original data frame. Like if you just check duplicated sum again, you are going to see the 65 again because you are not doing anything on modifying side of the original data frame. What you can do is you can just reassign it like this. This will work out, but what I mostly do is I will do in place equals to true, and after doing that it modifies the original data frame, and if you just check the duplicates again, they are going to be removed from the original data frame. Great, let's visualize the distribution of age. So for the distribution visualization, we are going to use histogram plot, and I will say plt.histogram, and I will say data frame age, and let's set the bins as 20, and let's set the color as sky blue, and let's set the edge color as black. So we are just going to give it a title like distribution of age, and we will just use X label, it's going to be age, and Y label, it's going to be frequency, and we will use plt.show at the end, and here is our distribution. So let me quickly show you what happens if you change the bins you can just make it 5 and you are going to see you can think it like the data bar counts. Like you can just change this to 10 and you are going to see 10 bars in here. And great, okay. We can see most of the players at the young age, like at their 20s, and least of them at their 40s. Great. So we are going to continue with doing some group bys, but before this I'm just going to recall our data frame, and at the weight side you are going to see they are not integers, like they have commas, and you can just check it like data frame wage, and the first entry, let's take an example entry, we are going to call that, we are going to get this, and let's just check the type of this, and you're going to see it's a string. So we need to change this for working with this since it's a numerical data. And how we can do that is we will say data frame wage, and we will use equal sign because we will say data frame wage, we will use replace, and we will use, like, we are going to open a dictionary, we will say replace this with empty string. So we are going to make this signs disappear with this, and after that we will say regex is going to be equal to true. And at the last step, what we are going to say is if we just use it like this, it's going to be still strings, and if we just use as type integer at the end, you are going to see that our data types are going to be also changed. And let's just call data frame wage and the first entry of it again, and you are going to see that it's an integer value, and you can just check its type, and we are going to see that it's integer. Great. So let's group our data by position and calculate the average wage. So what we are going to do is we will say data frame group by, and we are going to group by position, and we are going to take the values of wage, the mean of them, and here it is. So these are scientific numbers, and as long as this e plus 0.6 is same, you can just check like which is the highest one is the midfielder because 1.63 is greater than others, and the lowest is goalkeeper. And there's another ways to finding this, like you can just use sort values after this, and you can just use ascending false for sorting them in descending order, and you are going to see midfielder is going to be the highest and goalkeeper is going to be the lowest. Also, you can do various manipulations on this, like if you just write head 2, you are going to just get this 2 like this, and if you just write tail 3, you are going to get the last 3 and not the midfielder. Great, we are going to do that on our visualizations too. Okay, let's count the number of players in each club. So what we are going to do is we will say data frame club, and we will use value counts after that. So with this, we can see actually we have a lot of values in this side, and we can just use sort values, and we can say ascending false again for seeing the maximum ones, and here it is. I'm not really into football, so I can't understand is these values accurate or which league they belong to. Actually, we have them in our dataset, but I'm not used to that. I know this and I know Chelsea, but not much. Okay, let's create a bar chart of the top 10 nations with the most players. So what we are going to do is we will say data frame nation, and actually let me scroll a little bit, and I will say value counts after that, and we are going to say head 10, and you are going to see we are going to get this information, and we are going to set this as top nations, and after that we are going to do top nations dot plot. We will say kind is going to be equal to the bar, and we will say color is going to be, let's say, green, and we are going to give it a title like top 10 nations with the most players. Great, so we will say X label is going to be nation, and Y label is going to be number of players, and we will say plt.show at the end of this, and here it is. Great. So we can see that Spain is the first, Portuguese is the second, England is the third, France is the fourth, and goes like this. Great. So what we are going to do is we are going to get the value counts for the leagues. So we will say data frame league, and we will say value counts after that. And here it is. Premier League is the leading one in our data frame. Great, so at the next step we are going to create a scatter plot of age and number of international appearances. So let's do that. We will say plt scatter and we will use data frame age and we will use data frame caps. And after that, let's set the alpha as 0.5 and color as orange. So we are going to say plt title and we will do age versus number of international caps. It's appearances actually. We will say x label is going to be age and y label is going to be international appearances. And we will say plt.show. Actually, I'm not sure about the spelling of this, and let's do that. Great. So we can see that with the increase in age, there is an increase in international appearances, as it can be expected. Great. Okay, let's do some more group bys. We are going to group by club and calculate the total number of appearances and the average age. So how we are going to do that is we will say data frame group by, and we are going to group our data by club, and we will say aggregate. Then we are going to create a dictionary like this. We will say appearances and we will take the sum of this, and we will say age, and we are going to take the mean of this. And with this, great. So there's a data frame returned, and what we can do is if we want club to be also a column, we can just say reset index, and we are going to see club is going to be one of the columns right now. And let's just sort this like sort values, and let's set the by as, let's sort it by the appearances, and let's set this in descending order. Let's do ascending. After that we can do descending, and here it is. So we sorted this in the ascending order, and also we can do descending order like this, and great. So let's move to the next group by. We are going to group by position and find the maximum wage and the average number of international appearances. So for that we will say data frame group by, and we are going to say position, and we will say aggregation. Here we will create a dictionary again. We will say wage, maximum, and international appearances mean. Great. Also let's sort this by sort values, and let's sort this by wage in the descending order. And what we are going to see is the forward has the maximum wage. Actually it checks for individuals, like one individual forward entry has the maximum wage, so it passed midfielder here. But remember that at the average side midfielder was the leading one. Like we can just take the mean of this and you will see midfielder is the leading one. Great. Okay, let's create a bar chart of the top 5 clubs with the highest average age. So what we are going to do is we are going to set top clubs average age as data frame group by. We will say we are going to group by club, and we will say age, and we will take the mean of this, and we will use n largest, and we are going to set this as 5. And after that we are going to say top clubs average age dot plot. We are going to set the kind as bar and color as purple. And then we will say title is going to be top 5 clubs. Actually I need to write like title top 5 clubs with highest average age. And we are going to set the X label as club, and we are going to set the Y label as average age, and we will use plt.show at the end of this, and here it is. So we got the information we wanted. Okay, let's plot a pie chart of the distribution of players across different leagues. So we will say league distribution is going to be data frame league, and we will use value counts after that, and we will create a pie chart. So we will say plt.pie, then we are going to do league distribution labels is going to be equal to league distribution.index, and let's set the auto pct as you are going to see the difference. I'm going to remove that and I will show difference. It actually writes the percentages on the plot. And what we are going to do is let's set the start angle as 90. Great. So actually let me quickly check if there's a typo. I need F in here. Great. So we will say plt.title and we will say distribution of players across leagues. Great. Actually there's a typo, I think. Start angle it needs to be, so I need to add L in here. Also we can use plt.show. Great. So let me quickly show you by changing this. I will delete auto PCT, I will cut it, and with the change of this you are going to see we will lose these percentages on the plot. And it looks like this right now, but I generally prefer using this because I think it's more informative in this way. So I need to remove one of these and it's going to work out perfectly. Great. Now let's create a final chart and then we can move to the feature engineering part. We are going to group by club and plot a stacked bar chart of the total number of appearances for each club. So what we will say is, we will say club appearances and I will say data frame group by and club, and we will take the appearances in here like this. We will use sum and then at the end I'm going to add head 20 because it's going to be too complex if I don't add that. And I will say club appearances dot plot and I will say kind is going to be equal to the bar and I will say stacked is going to be equal to true, and let's set the color map like this. And then we are going to set the title like total appearances by club, and then I will say X label is going to be equal to the club and Y label is going to be appearances, and we will use plt.show at the end. Great. By the way, these are picked randomly since we are doing head 20 in here. You can just use .sort values and ascending false for getting the maximums. And after that what you can do is you can just run the cell like this and you are going to get maximum ones. Great. So it's all for the data analysis parts, and I think we covered a lot of stuff in the data analysis part and we can just move to the modeling side. Great. I'm not going to take all of the features at the model, so I will just call data, actually data frame, we set it like that, and I'm just going to eliminate some of the columns. Like I will take, actually we need to take the wage, but I'm going to take that at the end. It actually not change anything. I will take age, I will take, let's take the club, and let's not take position, I guess. We can take appearances and we can take appearances internationally, and we will take wage at the end. And let me quickly check if we can add anything else, and I think it's enough for the modeling. So we will have 4x values and 1 target value. So I'm just going to run this and the name data frame is going to be looking like this. Great. I think these are going to be the most effective on the wage side rather than the others like league, nation, position. And what we can do right now is we can just say we are going to change this club's data type into integers because we can't use it like this. We are going to do an encoding, we are going to use label encoder, and it's going to change these values into numerical values. So let's do that. We will say from scikit-learn import preprocessing, and we will say label encoder is going to be, we are going to initialize this class like preprocessing.label encoder, and what we are going to say is we will say data frame club and we will use label encoder fit and transform, and we will say club. Actually we need to say data frame club, and if we do that you are going to see that our club values are going to be numeric right now. Like let's just check it out, and at the club side we have different values. Actually there's a lot of clubs, I think. Let me quickly check. Yeah, there's a lot of clubs, so we have a lot of values in here. So I think club wasn't the best pick, so I'm just going to change this. Like, I'm just going to come in here and I will say data frame is going to be equal to the PD read CSV, and I'm just going to reread our data frame like salary prediction CSV, and at the data frame side we will have a brand new data frame. I'm just going to retaking it, and what I'm going to do is I'm just going to take the league instead of club right now. I will say league inside here, and after that when I call data frame we are going to have the league instead of club, and what we are going to do is we are going to use label encoder on the league so we won't have that much large numbers. So I'm just going to do that, and when I call the data frame again we have 1, 2, 3, 4, which represents this La Liga Premier League League 1 in here. So I think it's better now. So we will use age, league, apps and caps on explaining the wage. Also at the wage side we lost the thing that we have this signs in here. We need to change them and make wage numeric again. So I'm just going to copy this code real quick. Like, I'm just going to go upside and find that code. Let me quickly find that. Here it is. So I will just take this and come to the lower side, and when I run this you are going to see wage values are going to be changed. Like, if I call the data frame again we will have integers at the wage side. Great. So now we are going to set our x and target variable y. So what we will do is we will say x is going to be equal to the data ilog, and we will say this for taking all the columns, instead of the last one. So actually it's data frame, and you are going to see our x is going to be the first 4 columns. Great. So at the y side I'm going to say y is going to be equal to the data ilog, and we will say -1 for taking the last column we have, data frame. I'm just forgetting it, and at the y side we have the wages in here. Great. So we are going to use train test split right now. We use train test split a lot because we want to evaluate our model's performance and see how our model performs on the unseen data. Like, your model can perform really well at the training side, but it's not performing good at the test side. It's not usable because it's just remembering, it's not doing anything like prediction, and it didn't learn anything. So we are going to change this, and we can just check it by the train test split. So what we will say is we will say from sklearn.model selection import train test split, and we will say xtrain, xtest, ytrain and ytest. We will say train test split. We will give x, y, and we are going to give something like test size. Actually I need to use capital letter X, and at the test size we are going to say 0.2. Actually this test size is, if you put 0.2 in the test, like you are just putting your 80% of the data on the training side and 20% on the test side. Like, if you have 100 rows of data, 80 of them is going to be at the training if you do that. And you can just check it like xtrain, and you will see there is going to be actually 80% of the data, and you can just check the test data, you will get the same results. You are going to have 20% of the data. Great. So we have xtrain, xtest, ytrain, ytest right now, but we need to make another thing before starting the modeling. Like, all of these x values at a different scale, like appearances is pretty higher than age and league, which means this is going to affect more our model. Like, it's going to be not good, and we need to scale this data, and we need to put these 4 values at the same scale. So what we are going to do is we will use a scaler. Actually there's 2 types, min max scaler and standard scaler, which you can also refer as normalization, standardization. I'm going to use standard scaler right now. I will say from sklearn.preprocessing import standard scaler, and we are going to initialize this like scaler is going to be standard scaler, and after that we will say scaled xtest is going to be equal to the scaler.fit transform xtrain, and scaled actually we are just going to make this for the x's. I'm messed up. I will say train is going to be equal to the scalar fit transform, and I will say xtrain. Actually, at the upper side, I'm going to say test, and I'm going to run like that. So what happens now is, if you just call scaled xtest and scaled ytrain, you are going to see our values are going to be really lower, like xtrain. You are going to see that values are really lowered and they are at the same scale right now. Great. Some algorithms like tree-based models doesn't need scaling, like you can use it without scaling your data. It's not important, but some of them needs. I'm just going to use the scaled versions of the x values right here, and I'm just going to use them at the modeling side. You can do both. For the tree-based models, you can just use xtrain and xtest, and we can start the modeling right now. So for evaluating our model performance, I'm going to use root mean squared error and mean absolute error, and I'm going to define a function at the start for using that, and we don't need to write these lines again and again. So what we can do is, we are going to import numpy as np. We are going to use this for getting the square root of the mean squared error, and we are going to import mean absolute error and mean squared error from sklearn.matrix. So what we are going to do right now is, we are going to define a function as model results, and it's going to take the predictions we make with our model, and we are going to say print mean absolute error on model is, we will say dot format, and we are going to say mean absolute error y-test and predictions. The y-test is going to not change, and predictions is going to be changing with the models. Like with the linear regression model, we are going to send another predictions. With the support vector model, we are going to send another predictions at this side, and we will say print root mean squared error. Actually, I'm making a lot of typos on model is, and we will say that format, and we will give numpy square root. We will say mean squared error, and we will give y-test and predictions. And here is our function. It's ready. So we are going to use that on the evaluation of the model performances. Great. So let's start with a basic one. We are going to start with linear regression. We will say from sklearn.linear model import linear regression. And after that, we will say linear regression, and we are going to initialize this like this. And after that, we will say linear regression.fit, and we are going to fit it using scaled xtrain and ytrain, our training data. And after fitting this, and this means that training our model, we will do predictions with our model. So what we are going to do is, we will say linear regression.predict scaled xtest, and here is our predictions with the models for the y side, and we are going to set this like predictions linear regression. And after that, we are going to call our function, and we'll pass these predictions inside our function like model results, and we'll give the predictions we made. And here is our mean absolute error and root mean squared error on the model. These values can be good or bad on based on the problem and the values you are looking for. It really depends. We are just going to find the best performing model in this way, and you can use that in your problem. Great. So let's train a support vector regression model. So for that, we will say, actually, I'm going to use grid search for all the models, and I will do parameter tuning, which means that optimizing the model performance by finding the best settings. And what we will do right now is, I'm going to say from sklearn.model selection, I'm going to import grid search, which is going to help us on the parameter tuning for all the models. I will say from sklearn support vector machines import support vector regression. So at the next step, what we are going to do is, we are going to initialize this like SVR model is going to be equal to the SVR, and after that we will just define the parameters grid SVR. I'm going to create a dictionary like this, and for the C side regularization parameter, we can say 0.01, 0.1 and 0.5. I'm not going to create a lot of options in here. You can put as much as you want if you want a better model and try other things. For the kernel side, I will say linear, RBF and poly. And after that, I'm going to set also degree, like let's give 2, 3, and 4. Great, so here we have our parameters. Like we have this for C, this for kernel, this for degree. Great. At the next step, we are going to initialize our grid search cross-validation object. Actually, let's do this in another cell. I will say grid SVR is going to be equal to the grid search cross-validation, and we will say SVR model parameters grid SVR. And after that, we are going to say, actually, there's problem grid SVR. Let me quickly check what's the problem. Actually, I need this in here. This was the problem. And after that, what we are going to do is we are going to train our model like grid SVR.fit scaled x train and y train. And after training our model, I'm going to be right here. Great, so here we have our model, and what we can do is we can check the best performing parameters out of this, like for the C, kernel, and degree. And we can do that by print best parameters for model is, and we are going to use dot format. After that, we will say grid SVR dot best parameters, like this. And for the C, 0.5, for the degree 4, and for the kernel polynomial. So now what we can do is we are just going to create predictions. We are going to make predictions with this, like predictions grid SVR is going to be grid SVR dot predict, and we will use scaled x test for the prediction side, and we will say model results and predictions grid SVR. And here it is. Great. So let's train one final model before ending this video, and let it be random forest. So we will use random forest regressor, and we are going to train another model. So we are going to say from sklearn.ensemble import random forest regressor. And after that, what we are going to do is we are going to say random forest regression model is going to be random forest regressor. We are going to initialize this like this, and we are going to say grid RFR, and we will define parameters like, actually we need a dictionary. We will say max depth can be, actually lowercase, can be 5, 10, 15, and let's say maximum features can be auto and log2, and number of estimators can be, let's say 2, 5, 7, 10. Great, so we have 5, 10, 15 at the max step side and this at the other sides. Great, so now we will set grid RFR like grid search cross-validation. We will say RFR model, and actually we will give the parameters we just created. After that, we are going to use training data for training our model. Actually, it's a tree-based model and you can just use X-train, but I'm going to go with scaled X-train. Actually, there is not much difference, but on the tree-based models, you don't need scaling. I will say Y-train, and after fitting our model, here it is. So what we are going to do right now is let's check the best parameters like print best parameters for model is, and we will use dot format, and we will say grid RFR best parameters, and here it is. For the max depth it's 10, maximum features log2, and number of estimators 10. Great, let's make predictions with this. So we will say predictions grid RFR is going to be grid RFR dot predict. We will give the scaled x test, and after that we will get the model results with our function defined. So here it is. So here's our results. Great, so that was all for this video. Thanks for watching. I'm creating data science and programming content on my channel. You can subscribe for more. Also, I have more than 20 data science projects on my channel. You can just check the playlists page and you can find the data science projects on there. I also give free courses about data science and machine learning. You can also check them. Thanks again for watching my video and have a great day.